Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Good day. Our topic today is about stoichiometry. So we consider chromium 3 ion reacting with fluoride ion to form chromium 3 fluoride, as well as magnesium ion combining with the same anion to form magnesium fluoride. Now, all we have to do here is to balance the equation. So since we find 3F in the first equations in the right side, so we must add 3 as a coefficient of F, or F an ion in the first equation, and 2 in front of F minus in the second equation. So from the first equation, we see that 1 mole of Cr3 plus reacts with 3 moles of F minus. So we are basing this on the coefficients of the said ions in the balance equation. Now, we wish to find the mass of chromium and magnesium ion that will react with a certain amount of fluoride ion that's added through NaF solution to produce a precipitate which mass is given to be 49.6. So we say X is the mass of chromium ion, while Y is the mass of Mg. So before we proceed, let us note of the following molar masses. So we find these molar masses as, say, the atomic mass of the element or the sum of the atomic masses of the elements for a certain compound. So for Cr3 plus, note that this, although this is an ion, its mass is the same as the mass of the neutral element or the neutral atom. So the molar mass of the chromium ion is the same as the molar mass of Cr, which is 52. Whereas for Mg2 plus, it's 24.3. So by the way, the units for these are grams per mole, grams per mole. So molar mass of Cr F3 is 108, or that's 109. While for magnesium fluoride, it's going to be 62.3. Right? All right. So we are adding certain amount of fluoride ions to the solution containing the chromium and magnesium ion, and we solve this for step 1. We solve this as in terms of mole of NaF, which we get as concentration, or in terms of molarity, times the liters. So we have concentration as 1.51 times the liters. So your mole of NaF is equal to 1.51. And note that NaF ionizes completely into Na and F minus. And what we can see here is that for every mole of NaF, we have also 1 mole of F minus. So it follows that the mole of F minus is going to be equal to 1.51. Okay, now let's compute the moles of Cr that reacts with a fluoride ion. So we note that the mole of moles is equivalent to, okay, mass over molar mass, and we know that the mass, we let it as x, the molar mass is established as 52. We also do the same for magnesium. So we have y over 24.3. And let us convert this into mole of F minus. So what we will do is to relate the moles of the chromium and magnesium ions with the moles of F minus by using the relationship in the balanced chemical equation we have here. Okay, so recall that 1 mole of Cr minus needs 3 moles of fluorine ion over 1 mole Cr3 plus. So we get here 3x over 52, or that's it. Next, we get 4. We also have the moles of F minus reacting with the given moles of magnesium ion. Oops, this should be 2. Or this is going to be 2y over 24.3. Now it must be that the total moles of fluorine ion, which is equal to, we have it as 1.51, it must be equal to the moles of fluorine ion that reacts with a chromium ion and plus the moles of fluorine ion that reacts with magnesium ion. So we say we have 3x over 52, 24.3. Or let us just simply write it. Okay, I'm gonna use okay, fractional form for this. 3 over 52x plus, so we have 2 over 24.3, y equals 1.51. And let us say this is some equation 1. Okay, so we must also note that the moles from the same balance equation above, moles of the cation is equal to the same moles of the precipitate that it, of a fluid precipitate that it forms. So from here, we will be able to solve for the mass of the precipitate. So we have grams of Cr3 is going to be, so we may start with the moles of Cr3 times its molar mass, but what we know about the moles of Cr3 is that is just equal to the moles of the chromium ion, which is x over 52 times the molar mass. Let me just quickly check the molar mass again. So we have 109 times 109. So this is equal to, okay, And for the mass of magnesium fluoride, we have moles of Mgf2, which is equal to the moles of Mg ion Y over 24.3 times the molar mass, which is 62.3. Okay, let me just quickly check. Yes, it's 62.3. Okay, so or this is going to be so 62.3 over 24.3 y. And what we know is that the total mass of precipitate is equal to 49.6, and we know that this is equal to the mass of chromium fluoride and magnesium fluoride, where that's 109 over 52x plus 62.3 over 24.3 y. And let us name this as our equation 2. So what we got here are two equations with two unknowns, x and y. So they are, the first equation is this, okay? So 3 over 52 x plus 2 over 24.3 y and equals 1.51. And the other equation is 109 over 52. So as you can see, I'm not converting it to decimal. I'm keeping it as fraction in order to keep as much, or to make it to set the values in terms of its more exact form. All right, so we have two equations and two unknowns, so we can solve this using using a graphing calculator. If you want it longhand, you can use the substitution or elimination method, and the solution that you will get from here is the value of x and y that satisfies both equations of this system. So what I will do is that I'm going to use my calculator, plug it in, set it in system mode, and I'm going to plug in this set of equation here. So again, if you wanted to solve it longhand, you can use substitution or elimination method, which you can review in algebra. So here I got 8.57. That's for my x, and then for my y, which is going to be 12.3. Okay, so again, x is the mass of Cr, or chromium 3 ions, while the y is the mass of your magnesium ions. So here. So if you're just asked of the mass of the chromium ion, then you report 8.57 grams. I hope that's clear.